So we've talked about how to use elimination to solve a system of equations, but the systems that we were solving before only had two variables. So something like this: x plus 2y equals 8, let's say, and 3x plus 6y equals 7. Two equations with two variables. In this video, I want to show you a little bit more challenging type of problem. That's how to solve a system with three variables. So not just x and y, but this time we'll add a z in as well. Okay, the important thing to note is however many variables you have, that's how many equations you need. So here we have two variables, x and y. That means we have two equations. Okay, in this example, we're going to have three equations. So the steps that you see here are the steps that we're going to follow, and they're not going to make sense until we do an example. But basically, the idea is we need to pick a variable to eliminate. There's going to be three equations. We'll use two of them to eliminate. That's our first step. Our second step right here is that we're going to go back and eliminate it again using the third equation, the one that we haven't used yet. And then step 3 is when we do those first two steps, we'll be down to a problem like this right here that we know how to solve. So this will be clearer when we do some examples. So let's take a look. Okay, in this example, we need to pick a variable to eliminate. It doesn't matter which one. The only important thing is we have to stay consistent throughout the whole problem. So if we pick x, that's what we're going to have to eliminate the second time. So it doesn't really matter. I am going to pick x because there's a 1x right there. It's usually easier to eliminate things with ones in them. So I'm going to eliminate x, and we'll stick with that throughout. Okay, then notice we have three equations here. We have a, we'll call these equations a, b, and c. It doesn't matter which ones you pick to eliminate. I'm going to pick equation c and equation b to start with. Okay, so we're going to pick equations, and EQS is just an abbreviation for equations. Equations B and C. Part of the challenge on these problems is keeping your work organized because there's a lot of stuff going on. So I'm going to rewrite equation B right there. Negative 2x minus 2y plus 5z. There is equation B, and then underneath it I'm going to rewrite equation C. And we've chosen to eliminate the x. How would we eliminate the x? The answer is we need those both to be two x's. Right now this is a 1x. So the way that we'll eliminate that is by multiplying the bottom one by 2 and then distributing. So when we do that, the top is going to stay unchanged. The top is still the exact same. So that doesn't change at all. The bottom, though, when I distribute, 2 times x is 2x, 2 times 6y is 12y, 2 times 6z is 12z, and 2 times 18 is 36. Okay, now the question is, how do we eliminate the x's? By adding or subtracting? And the answer is we have to add these. So those will eliminate. That means we have to add these. Negative 2y plus 12y would be 10y. 5 plus 12z would be 17. Sorry, that's not supposed to be a 12. It's supposed to be a 17. 17z. And then finally the last one, negative 3, that's 17z. Negative 3 plus 36 would be 33. Here's a suggestion I would make. When you get to this point that you've eliminated a variable, let's box this off. And the reason we're boxing it off is because you can see already there's a lot of work on this page, and we've only done the first step. And that's part of the challenge of these problems, is that there's quite a few steps to keep track of. Okay, well this is a good sign. We're about almost halfway there. So we've now eliminated. Now we have at least an equation that looks similar to what we did before. There's only two variables in it. Okay, now here's the important step. We need to do this. This right here was elimination number 1. We need to do a second elimination right here, and I'll do it right here. Elimination. Let me just clear this off. Again, just to remind ourselves, we're eliminating the x's. Now we're going to do elimination number 2 up here. And elimination number 2 needs to eliminate the x again. Now here's the key thing. We need to use the only equation that we haven't used so far. Okay, so in the first one we used b and c. So now we're going to use either of those first two. I'm just going to pick c. It doesn't matter. Okay, but I'm going to pick c, and the only one we haven't used yet is this one. We haven't used a. So we have to use a for our second elimination. We must use the third equation, meaning the one that we haven't used yet. So let me rewrite those two. So here is equation A right here. And then underneath that, I'm going to write equation C. You didn't have to choose C, but it seemed easiest in this case. So 6y plus 6z equals 18. And now again, we have to eliminate the x's. How can we eliminate the x's? Well, I need this bottom one to be 6x. So I'm going to multiply everything in here by 6x and distribute. The top one is going to stay unchanged. It's going to be 6x. Let me just rewrite this. 6x plus 5y minus z is equal to negative 10. The bottom, when you distribute, becomes 6x plus 6 times 6 is 36y. 6 times 6z is 36z. And 6 times 18 is 108. Okay, how do we eliminate the x's? Well, this time we have to subtract them, and that means we have to subtract everything else. So those go away. 5 minus 36 is negative 31y. Negative z minus 36 would be negative 37z. And negative 10 minus 108 is negative 118, I should say. Now I'm going to take that equation and I'm going to just move it down below where the other one is. So down here, we'll box it off just to indicate that's what we wanted. I'm going to move it right below here. So negative 31y minus 37, that's a 7 right there, 37z equals negative 118. Okay, so now what do we need to do? We basically need to find a common denominator here. We need to eliminate just like we were used to doing before. And these numbers are not the easiest to work with, but that's okay. Oftentimes the way that these are set up, they turn out to be nice, neat numbers at the end. Okay, so we need to eliminate one of the two. I think y is a little bit easier to eliminate because 17 and 37, the z numbers, those are both prime numbers. At least 10, one of the numbers in front of y is 10, so that's slightly better. So there's no obvious way to change 10 into 31 or 31 into 10, so when there's not, you can just multiply them together. So the 10 on top, I'm going to multiply that by 31, and everything gets multiplied by 31, and the 31 on the bottom, I'm going to multiply by 10, because that will create a common multiple, which is what we need. So when we distribute to the top, 31 times 10y is 310y. 31 times 17, what's that? 310 plus 217 would be, I think, 527z. Okay, normally the numbers are not quite so large. And then 31 times 33 is 1,000. What is that? 1,023, I think. Okay, the bottom, 10 times negative 31 is negative 310y. 10 times negative 37z is negative 370z. And this one's obviously easy to multiply because 10 is not hard to do. And then 10 times negative 118 is negative 1180. How do we eliminate the z's, or sorry, how do we eliminate the y's, because that's the one that we chose? We would do that by adding them together. So let's add these, so those go away. 527 plus negative 370 would be 157z. Okay, and then 1023 plus negative 1180 is actually negative 157. So you can see, even though those numbers are kind of messy, these are going to work out pretty nice. So negative 157 divided by 157 means that z is equal to negative 1. Okay, here's the thing. All of the hard work has been done at this point. Now that we have one of the variables, the only thing that we need to do from there is just to substitute it back in. Now here's the problem. Look at this page. It's filled with equations. Which one will we substitute it back into? And the answer is we substitute it into either this one here or this one here. Here's the reason why. If we went back to the original, okay, the original is way up here, there's 3. If we substitute z in right here, let's say, or one of the other ones, we're still going to have 2 variables in there, and then we have a problem. We can't solve it when there's 2 variables, or we can, but it's going to be extra work. It's much easier to substitute it in when there's only one other variable. So let's just take this one because it's close by. So negative 31y minus 37 times z, and we know from right here that z is negative 1, so that's what I'm going to put in there right there. Okay, then this is positive 37, so let's rewrite that. Negative 31y plus 37 equals negative 118. Then we'll subtract 37 from both sides, and we will get negative 31y is equal to negative 155. When you divide by negative 31 both sides, you get y equals positive 5. So now that we have both z and y, we know that z is negative 1, y is 5. I'm going to come back up to the very top where the x's are, and we'll solve it right there. So let's just keep a running tally of our answer. The way we're going to write it is x, y, and z in alphabetical order. So the y was 5, the z was negative 1. All we need right now is x. So let's plug in our 2 values right here. Doesn't matter which one we picked, but that one was close by. So 5 times y becomes 5 times 5, and minus z becomes minus negative 1. Okay, so then this stuff simplifies. 5 times 5 is 25, minus negative 1 is like plus 1. So 25 plus 1 would be 26, and that's equal to negative 10. Now we'll subtract 26 from both sides, and we will get 6x equals negative 36. That means when we divide both sides by 6, we get x equals to negative 6. So that goes right here. It would, of course, be possible to check this. You could take those numbers and plug them back into all three of these equations. That would be a little bit extra work, but if you really want to be sure that you have it, that's how you would do it. Okay, but that's a three-variable system. In the next video, I'm going to show you, we had one solution right there. In the next video, I want to show you what does it look like when you actually don't have a solution, when you have one of those special cases like infinite or no solution. So that's coming up next.